Okay, we're going to go through a real quick walkthrough of a basic hookup for the LCD module, which is this part right here. It stands for liquid crystal display, and it's commonly referred to as a 1602 because it is 16 columns by 2 rows on the display, and that will be modified in the code. You can easily add in a 1604 module, and it's wired the exact same way and programmed the same way. But I'm going to show you a quick wiring for that. Truthfully, I did the wiring on this project just because it worked out very nicely to show the wiring. Coming in the program that we're going to try uploading. And I like to include the wiring in here, the ESP to whichever module, which I guess in this, I should modify this and say the LCD 1602 module. And we have the ground wire, and it goes to ground and it jumps to the RW pin and the LED negative pin on that same module, the 5 volt. This one here, the V0, is already connected internally on the circuit board, and that's because that contrast potentiometer always needs to be there. So we just wired that into the kit to make it easier, kind of like the current limiting resistors on the LEDs are all built in so we don't burn anything out and have to look up resistor color codes. And the other wiring here, your I/O pins and how they correspond to your module are all outlined there. I also like to include this little line commented out. The 2 lines are a comment, and this is how the GPIO pins relate to LCD pins, and I find that helpful. And then you'll see, of course, our 2 loops, the setup loop, which is run one time, and then there's a loop the loop function that will continue over and over. And we did put some LCD print in here. If you want to print text on your LCD, you could put it in quotes. Down here we did some dynamic text, and we pulled from that Mills counter that starts as soon as your microprocessor is booted. And you can also set the rows and columns, or columns and rows, a position on it. So what I did is I set it to the first row and the first column and the second row, and I told it to print the word seconds, and then we just displayed mils and divided it by 1,000, because remember, a mils is 1,000th of a second. And this is the code that we're running on our Arduino kit, and I'll show you that here. And if I reset it, hit the reset button up here, and that will reset the mils timer. And there's my static text, the DuinoKit IoT, and then my dynamic text down here with the countdown and the seconds. So you can see how that works. This is the contrast knob. If you do not have any display on your kit, you may need to turn this knob and adjust it. And if your battery voltage changes, you may need to adjust that on these displays. The one display that doesn't have an adjustment is this little guy right up here, this OLED display. It just always works a little bit better, but it's not quite as large of a display. A little bit harder to program. We'll get to that in the future. And that will show you basic instructions on wiring up the LCD display. I would encourage you to try and change the pin wires around. Change these wires, but make sure your code matches whichever wire it's running to on the LCD pins. And I'll let you go with that. There are a couple challenges on here, so make sure you attempt those challenges and see how those work out.